As seen from the Earth, a solar eclipse is a type of eclipse that occurs when the Moon passes between the Sun and Earth, and the Moon fully or partially blocks the Sun. This can happen only at new moon, when the Sun and the Moon are in conjunction as seen from Earth in an alignment referred to as syzygy. In a total eclipse, the disk of the Sun is fully obscured by the Moon. In partial and annular eclipses, only part of the Sun is obscured. If the Moon were in a perfectly circular orbit, a little closer to the Earth, and in the same orbital plane, there would be total solar eclipses every month. However, the Moon's orbit is inclined at more than 5 degrees to the Earth's orbit around the Sun, so its shadow at new moon usually misses Earth. Earth's orbit is called the ecliptic plane, as the Moon's orbit must cross this plane in order for an eclipse to occur. In addition, the Moon's actual orbit is elliptical, often taking it far enough away from Earth that its apparent size is not large enough to block the Sun totally. The orbital planes cross each other at a line of nodes, resulting in at least 2, and up to 5, solar eclipses occurring each year, no more than 2 of which can be total eclipses. However, total solar eclipses are rare at any particular location because totality exists only along a narrow path on the Earth's surface traced by the Moon's shadow or umbra. An eclipse is a natural phenomenon. Nevertheless, in some ancient and modern cultures, solar eclipses have been attributed to supernatural causes or regarded as bad omens. A total solar eclipse can be frightening to people who are unaware of its astronomical explanation, as the Sun seems to disappear during the day and the sky darkens in a matter of minutes. Since looking directly at the Sun can lead to permanent eye damage or blindness, special eye protection or indirect viewing techniques are used when viewing a solar eclipse. It is technically safe to view only the total phase of a total solar eclipse with the unaided eye and without protection. However, this is a dangerous practice, as most people are not trained to recognize the phases of an eclipse, which can span over 2 hours, while the total phase can only last up to 7.5 minutes for any one location. People referred to as eclipse chasers or umbraphiles will travel to remote locations to observe or witness predicted central solar eclipses. For the date of the next eclipse, see the section Recent in Forthcoming Solar Eclipses. Types. There are 4 types of solar eclipses. A total eclipse occurs when the dark silhouette of the Moon completely obscures the intensely bright light of the Sun, allowing the much fainter solar corona to be visible. During any one eclipse, totality occurs at best only in a narrow track on the surface of Earth. An annular eclipse occurs when the Sun and Moon are exactly in line, but the apparent size of the Moon is smaller than that of the Sun. Hence the Sun appears as a very bright ring, or annulus, surrounding the dark disk of the Moon. A hybrid eclipse shifts between a total and annular eclipse. At certain points on the surface of Earth it appears as a total eclipse, whereas at other points it appears as annular. Hybrid eclipses are comparatively rare. A partial eclipse occurs when the Sun and Moon are not exactly in line and the Moon only partially obscures the Sun. This phenomenon can usually be seen from a large part of the Earth outside of the track of an annular or total eclipse. However, some eclipses can only be seen as a partial eclipse, because the umbra passes above the Earth's polar regions and never intersects the Earth's surface. Partial eclipses are virtually unnoticeable, as it takes well over 90% coverage to notice any darkening at all. Even at 99% it would be no darker than civil twilight. http://www.heliodyssey.org/eclipse_facts.html. The Sun's distance from Earth is about 400 times the Moon's distance, and the Sun's diameter is about 400 times the Moon's diameter. Because these ratios are approximately the same, the Sun and the Moon as seen from Earth appear to be approximately the same size, about 0.5 degree of arc in angular measure. A separate category of solar eclipses is that of the Sun being occluded by a body other than the Earth's Moon, as can be observed at points in space away from the Earth's surface. Two examples are when the crew of Apollo 12 observed the Earth eclipse the Sun in 1969 and when the Cassini probe observed Saturn eclipsing the Sun in 2006. The Moon's orbit around the Earth is an ellipse, as is the Earth's orbit around the Sun. The apparent sizes of the Sun and Moon therefore vary. The magnitude of an eclipse is the ratio of the apparent size of the Moon to the apparent size of the Sun during an eclipse. An eclipse that occurs when the Moon is near its closest distance to Earth can be a total eclipse because the Moon will appear to be large enough to completely cover the Sun's bright disk, or photosphere. A total eclipse has a magnitude greater than 1. Conversely, an eclipse that occurs when the Moon is near its farthest distance from Earth can only be an annular eclipse because the Moon will appear to be slightly smaller than the Sun. The magnitude of an annular eclipse is less than 1. Slightly more solar eclipses are annular than total because, on average, the Moon lies too far from Earth to cover the Sun completely. A hybrid eclipse occurs when the magnitude of an eclipse changes during the event from less to greater than 1. So the eclipse appears to be total at some locations on Earth and annular at other locations. Because the Earth's orbit around the Sun is also elliptical, the Earth's distance from the Sun similarly varies throughout the year. This affects the apparent size of the Sun in the same way, but not as much as does the Moon's varying distance from Earth. When Earth approaches its farthest distance from the Sun in July, a total eclipse is somewhat more likely, whereas conditions favor an annular eclipse when Earth approaches its closest distance to the Sun in January. Terminology for central eclipse. Central eclipse is often used as a generic term for a total, annular, or hybrid eclipse. This is, however, not completely correct. The definition of a central eclipse is an eclipse during which the central line of the umbra touches the Earth's surface. It is possible, though extremely rare, that part of the umbra intersects with the Earth, but not its central line. This is then called a non-central total or annular eclipse. The last non-central solar eclipse was on April 29, 2014. This was an annular eclipse. The next non-central total solar eclipse will be on April 9, 2043. The phases observed during a total eclipse are called first contact, when the Moon's limb is exactly tangential to the Sun's limb. Second contact, starting with Bailey's beads and the diamond ring effect. Almost the entire disk is covered. Totality, the Moon obscures the entire disk of the Sun and only the solar corona is visible. Third contact, when the first bright light becomes visible and the Moon's shadow is moving away from the observer. Again a diamond ring may be observed. Fourth contact, when the trailing edge of the Moon ceases to overlap with the solar disk and the eclipse ends. Predictions. Geometry. The diagrams to the right show the alignment of the Sun, Moon and Earth during a solar eclipse. The dark gray region between the Moon and Earth is the umbra, where the Sun is completely obscured by the Moon. The small area where the umbra touches Earth's surface is where a total eclipse can be seen. The larger light gray area is the penumbra, in which a partial eclipse can be seen. An observer in the antumbra, the area of shadow beyond the umbra, will see an annular eclipse. The Moon's orbit around the Earth is inclined at an angle of just over 5 degrees to the plane of the Earth's orbit around the Sun. Because of this, at the time of a new moon, the Moon will usually pass to the north or south of the Sun. A solar eclipse can occur only when new moon occurs close to one of the points where the Moon's orbit crosses the ecliptic. As noted above, the Moon's orbit is also elliptical. The Moon's distance from the Earth can vary by about 6% from its average value. Therefore, the Moon's apparent size varies with its distance from the Earth. And it is this effect that leads to the difference between total and annular eclipses. The distance of the Earth from the Sun also varies during the year, but this is a smaller effect. On average, the Moon appears to be slightly smaller than the Sun as seen from the Earth, so the majority of central eclipses are annular. It is only when the Moon is closer to the Earth than average that a total eclipse occurs. The Moon orbits the Earth in approximately 27.3 days, relative to a fixed frame of reference. This is known as the sidereal month. However, during one sidereal month, Earth has revolved part-way around the Sun, making the average time between one new moon and the next longer than the sidereal month. It is approximately 29.5 days. This is known as the synodic month, and corresponds to what is commonly called the lunar month. The moon crosses from south to north of the ecliptic at its ascending node, and vice versa at its descending node. However, the nodes of the moon's orbit are gradually moving in a retrograde motion, due to the action of the Sun's gravity on the moon's motion, and they make a complete circuit every 18.6 years. This regression means that the time between each passage of the moon through the ascending node is slightly shorter than the sidereal month. This period is called the nodical or draconic month. Finally, the moon's perigee is moving forwards or precessing in its orbit, and makes a complete circuit in 8.85 years. The time between one perigee and the next is slightly longer than the sidereal month and known as the anomalistic month. The moon's orbit intersects with the ecliptic at the two nodes that are 180 degrees apart. Therefore, the new moon occurs close to the nodes at two periods of the year approximately 6 months apart, known as eclipse seasons, and there will always be at least one solar eclipse during these periods. Sometimes the new moon occurs close enough to a node during 2 consecutive months to eclipse the Sun on both occasions in 2 partial eclipses. This means that, in any given year, there will always be at least 2 solar eclipses, and there can be as many as 5. Eclipses can occur only when the Sun is within about 15 to 18 degrees of a node. This is referred to as an eclipse limit. In the time it takes for the moon to return to a node, the apparent position of the Sun has moved about 29 degrees relative to the nodes. Since the eclipse limit creates a window of opportunity of up to 36 degrees, it is possible for partial eclipses to occur in consecutive months. Path during a central eclipse, the moon's umbra moves rapidly from west to east across the Earth. The Earth is also rotating from west to east, at about 28 km per minute at the equator. But as the moon is moving in the same direction as the Earth's spin at about 61 km per minute, the umbra almost always appears to move in a roughly west-east direction across a map of the Earth at the speed of the moon's orbital velocity minus the Earth's rotational velocity. The width of the track of a central eclipse varies according to the relative apparent diameters of the Sun and Moon. In the most favorable circumstances, when a total eclipse occurs very close to perigee, the track can be up to 267 km wide and the duration of totality may be over 7 minutes. Outside of the central track, a partial eclipse is seen over a much larger area of the Earth. Typically, the umbra is 100 to 160 km wide, while the penumbral diameter is in excess of 6,400 km. Duration. The following factors determine the duration of a total solar eclipse: the moon being almost exactly at perigee, the Earth being very near aphelion, the midpoint of the eclipse being very close to the Earth's equator, where the orbital velocity is greatest, the vector of the eclipse path at the midpoint of the eclipse aligning with the vector of the Earth's rotation, the midpoint of the eclipse being near the subsolar point. The longest eclipse that has been calculated thus far is the eclipse of July 16, 2186. Occurrence and cycles. Total solar eclipses are rare events. Although they occur somewhere on Earth every 18 months on average, it is estimated that they recur at any given place only once every 360 to 410 years, on average. The total eclipse lasts for only a maximum of a few minutes at any location, because the moon's umbra moves eastward at over 1,700 km per hour. Totality currently can never last more than 7min32s. This value changes over the millennia and is currently decreasing. By the 8th millennium, the longest theoretically possible total eclipse will be less than 7min2s. The last time an eclipse longer than 7 minutes occurred was June 30, 1973. Observers aboard a Concorde aircraft were able to stretch totality to about 74 minutes by flying along the path of the moon's umbra. The next total eclipse exceeding 7 minutes in duration will not occur until June 25, 2150. The longest total solar eclipse during the 11,000-year period from 3000 BC to at least 8000 AD will occur on July 16, 2186, when totality will last 7 min 29s. For comparison, the longest total eclipse of the 20th century at 7 min 8s occurred on June 20, 1955, and there are no total solar eclipses over 7 min in duration in the 21st century. If the date and time of any solar eclipse are known, it is possible to predict other eclipses using eclipse cycles. The Saros is probably the best known and one of the most accurate. A Saros lasts 6,585.3 days, which means that, after this period, a practically identical eclipse will occur. The most notable difference will be a westward shift of about 120 degrees in longitude and a little in latitude. A Saros series always starts with a partial eclipse near one of Earth's polar regions, then shifts over the globe through a series of annular or total eclipses, and ends with a partial eclipse at the opposite polar region. A Saros series lasts 1226 to 1550 years and 69 to 87 eclipses, with about 40 to 60 of them being central. Frequency per year: between 2 and 5 solar eclipses occur every year, with at least one per eclipse season. Since the Gregorian calendar was instituted in 1582, years that have had 5 solar eclipses were 1693, 1758, 1805, 1823, 1870, and 1935. The next occurrence will be 2206. On average, there are about 240 solar eclipses each century. Final totality total solar eclipses are seen on Earth because of a fortuitous combination of circumstances. Even on Earth, eclipses of the type familiar to people today are a temporary phenomenon. Hundreds of millions of years in the past, the Moon was too close to the Earth to precisely occlude the Sun as it does during eclipses today, and over 1 billion years in the future, it will be too far away to do so. Due to tidal acceleration, the orbit of the Moon around the Earth becomes about 2.2 centimeters more distant each year. It is estimated that, in slightly less than 1.4 billion years, the distance from the Earth to the Moon will have increased by 30,400 kilometers. During that period, the angular diameter of the Moon will decrease in size, meaning that it will no longer be able to completely cover the Sun's disk as seen from the Earth. This will be true even when the Moon is at perigee, and the Earth at aphelion. The Sun is also increasing in diameter by about 5% per billion years. Therefore, the last total solar eclipse on Earth will occur about 600 million years from now.